Hey everybody. So, our lesson today is going to be on evaluating function expressions. So what that means, basically, you're familiar with evaluating functions in terms of what if we had f of x equals 3x minus 5, and we asked you to find f of negative 2. All that really means is plugging in negative 2 for x. 3 times negative 2 is negative 6. And negative 6 minus 5 is negative 11. So that's regular evaluating functions. So that's evaluating functions at an x value. Now, evaluating function expressions, or evaluating functions with expressions, is about, like, what if you had f of x equals 3x minus 5, and you were asked to evaluate it at f of negative 2x, okay? So this may seem kind of weird, but basically it's still the same thing. X is being replaced with negative 2x. So you're not going to find a answer that's just a number, the way we had negative 11 a second ago. It's just that f of negative 2x, 3 times negative 2x is negative 6x, and this would be your final answer, negative 6x minus 5. So this isn't evaluating the function at an x value to find a number. It's evaluating the function if you plugged in another expression as your x. Okay? So there's a few different ways this can go down. So one of the easier things is sometimes you get stuff added or subtracted outside of your f of x. So say that your f of x is negative 5x minus 1. And then you're asked to evaluate f of x minus 2. Well, this minus 2 is outside the parentheses. So what you have right here, f of x, well, I know what that is. F of x is negative 5x minus 1. That's your f of x part. And then, after you have all that, we have minus 2. That just gets tacked onto the end because it is not part of the f of x thing, which is, not disturbed at all by that minus 2. So then you have negative 5x, and then you have minus 1 minus 2 gets me to negative 5x minus 3. So f of x minus 2 is negative 5x minus 3. Versus, pay close attention, if I have x minus 2 in parentheses, so the minus 2 is in parentheses, now it's part of what gets x, replaces x. Now x gets replaced with x minus 2. Okay? So you keep these separate. So we got distributive property here, negative 5 times x minus negative 5 times 2. This turns into one big plus sign. We've still got our minus 1. This one's more complicated, right? And then we've got 10 minus 1 is 9. So that is the difference that the parentheses makes. If it's f of x, then it's just your f of x, and you tack on minus 2 at the end. If the minus 2 is inside the parentheses, and now it's part of the x, then you plug it in as part of the x, and you have to simplify. So that's the difference between outside parentheses and inside parentheses. Let's do some more examples. F of x equals x minus 5x squared. And I'm asked to find negative f of x. So this negative is outside the f of x. So that means we put a negative outside, and then the entire f of x inside. Like that. So essentially we have to distribute that negative sign. Negative x minus negative 5x squared, which of course gets us double minus negative x plus 5x squared. So this is something to take note of, a good example to notice. What happened when we put a negative in front of f of x? The positive x turned to negative x, then minus 5x squared turned to plus 5x squared. Essentially, negative in front of the whole thing means every term switches signs. Positive went to negative, negative went to positive. So that's what putting a negative in front of the f of x does. But he's cool with that. Versus, what if I put the negative inside f of negative x? Okay. That means that wherever you see x, you replace it with negative x. So this x became negative x, and this x became negative x. Now, what is negative x squared? So x times x is x squared. Negative x times negative x. Negative times a negative is a positive. X times x is x squared. So this is kind of funny and cool and something you got to notice. Negative x squared is just the same as x squared when the negative is inside the parentheses. So this didn't change. Over here, we've got minus negative x. It's not squared. There's nothing that cancels out, anything like that. So this ends up being 6x squared plus x. Double minus makes plus. So that is, if this is f of x, this is f of negative x, function of negative x, 6x squared plus x. This one stayed the same because a negative squared stays the same. And this one turned positive because a negative negative turns positive. Okay. All right. F of x plus 3. So again, f of x is by itself here. It doesn't have anything interfering inside the parentheses, which means we can just rewrite it exactly as is. And then, after we've gotten f of x down, plus 3, we just tack on a plus 3. So we still got to simplify it. Minus 5 plus 3, negative 5 plus 3 is negative 2. So that would be your final answer for that one. Again, the plus 3 outside the f of x means you just tack it on to the end. Okay. Then I have a good last one for you. F of 3x. So this 3 is inside the parentheses, right? Inside the parentheses means that we don't multiply the whole thing by 3, just replace the x with 3. Okay? So everything else is the same, except that x got replaced with 3x. So that means now we're talking 3x squared. So 3x squared is 3x times 3x, right? 3x times itself. 3 times 3 is 9. X times x is x squared. Three times 9x squared is 3 times 9 is 27. So negative 1 plus 27x squared. And that is some examples of plugging in an expression and evaluating a function at an expression. Woohoo, less than 12 minutes.